Okay, so here's code for perform birth. We notice it does something, it returns void. In other words, it just simply accomplishes something, it takes nothing as an argument. So this is the code. Could anyone help me parse sort of what this code is doing? What steps is it undertaking here?
So is the first line asking mothers to perform the action? And what will follow?
Okay, it's a good guess, but it turns out that this is doing what's called declaring a variable.
Okay.
So it's just actually, this is just for clarity, saying let's have this variable whose value will actually be just this, but it'll be sort of it'll make it clear that when we refer to this, we're actually referring to the mother, because we're telling a particular person in the population, a will-be mother, perform birth, and really this is the person that's going to be performing birth. So that's the mother. Does that make sense?
Yes.
Okay, what does the second line do? What is,
We're creating an offspring because we're creating a variable.
that's right, we're creating a variable, and it's going to be a convenient sort of reference to this offspring, which is being added to the population. What does this add population do? First of all, whose method is that we're calling here? It's a that's right. It's created by AnyLogic. And where does it live? It lives in main. By the way, to be really clear about this, I mean, this is always like get the main associated with me. It's not. It works fine either way, but just semantically, it's clear. Get my main, and now add. Hey, you main. Add for me someone to the population who is of age 0, who has my same ethnicity, who's of a random sex, and whose infection status is, you could see this. So earlier, Carmel was asking, where's that information defined? If you look at this, the first thing is the age, initial age. Second thing is the ethnicity of the baby. Third thing is the sex of the baby. So the ethnicity is the same as me, but the sex is not necessarily the same as the mom. Whether it's initially infected and who the mom is. So what is this? The fact that I passed this, what is this capturing?
So it's the mom's infection status being passed to the child.
That's right. In short, this is capturing vertical infection. One to baby transmission. When the baby is born, it's born with the mom status. Now, by the way, this is one way to capture it. Now, if we wanted to capture just probabilistic transmission, like vertically, so there's if the mom's infected, there's an 80% chance that the baby's infected. We could do so. We'd probably do that best in another line, but another way would be to actually say something like random true. If now this is I would do this on another line, but so this is what I would do if I wanted to do that. Double probability of vertical transmission equals, if the mom is infected, really this should be done, maybe it's 80% probability, otherwise it's 0. And then I'd say random true of probability of infection. Really, somewhere there should probably be a parameter called probability of vertical transmission instead of hard coding it here, so I could go modify it. Okay, so I'll go for this case, I'll make a probability of vertical transmission given infected mom, infected mother versus 0. So what is this long contorted line saying? this is a double over here. So it's introducing a what? Variable whose value is, if the mother is infected, by the way, to be clear, just to sort of follow my nice naming convention, this is mother dot is infected. If the mom is infected, then what? Then this probability is, well, this will be the probability, this will be some parameter, otherwise it will be 0. Okay? And this parameter here, I think I'm going to make it live and get main, because it doesn't vary by particular person. It's once for the entire thing. Okay, so now we have this offspring, this random true. What this is now doing is, with that probability, it's true. Otherwise, it's false. So it's a draw from a Bernoulli. It's a Bernoulli draw. So with a certain probability, it's true. Otherwise, it's false. Okay. And then mother is just me. It's just this current person. Okay, so we have a reference to this offspring that's returned. That person is also added to the population. This added them to the population. But there's a reference to them. So then what does this do? This line. Yeah, and it prints out. It prints out this news, the baby's ID is this, well, the mother's is such and such. Okay, what's this / thing? It's a comment. Establish connections of infant. So, what is this thing? And what are these things?
Adding the baby to the mom's network.
Yeah, exactly. And in order to do its job, in order to add them in, you need to tell who the baby is and who the mom is, and that will do the work. Similarly, now position baby close to be mother. And so establish offspring location based on mother's connection location. So it establishes the offspring. And then finally, what do you think this does? It adds to the collection. It adds the baby to the collection. So that's what this method does.
I have two questions.
Yes.
First of all, when you're adding to the population,
Yeah.
term ethnicity, how do you know you're adding the same ethnicity as moms?
Great question. So what is this ethnicity referred to? Well, to be clear here, it would be better if I referred to it as this ethnicity. Okay. And actually, what it's referring to is in fact the ethnicity parameter of the mom. So in other words, this mom has, probably the easiest thing to do given the size of this is to look here and see she has an ethnicity. Okay? Here? So in that code, that reference to the ethnicity of the, that code for performed birth, in that so-called parameter being passed or argument being passed to the to this add population, it's actually passing the population of the mom as that ethnicity to create for the baby, and that becomes, this value gets taken, whatever the value is, it gets taken and it's used as the parameter for the baby now in creating the baby, just as if it were defined in that population for, in Maine, this population. So in this embedded objects here, in this population, you can specify for the people in the population what's the rule for setting their ethnicity. Just as if I had said there, use this ethnicity. In this case, it's creating a single person in the population, this add population, and it's going to use the mom's ethnicity, separate ethnicity of the child. Does that make sense?
Yeah.
Yeah.
And then my second question.
Sure.
You go back to.
Okay. Would you mind if I just added a parameter to main while I've got it still in my clipboard? So here I'm going to add it. Ooh, got to be careful here. Let's open main. And let's add in a parameter here. So here we have a parameter, okay, that's called probability of vertical transmission, and if no one specifies a value for it, I'll make it 80% likelihood of vertical transmission, and just as a matter of kind of cleanliness, I'd like to put it. Oh man, well, okay, I'll have someone or myself clean it up before we disseminate it too widely, but we'll get it up there. It's up for the class immediately. But yes, so Carmel, you were asking the second question.
Do you have the?
Yeah, sure. So here's perform birth. Okay, yeah.
So on that quote,
Yep.
I think it makes sense to me, except for when you're saying the probability of vertical transmission.
Mm-hmm.
You say mother dot is infected, and then you switch it to this dot get main.
Oh gosh. Yeah, I mean, it really should be mother.getMain.
Can you just use mother and this interchangeably there, since you defined person?
I defined, so the deal was, for this very first line, I could have called everything this. Gosh, sorry. I'm not being sufficiently clear about it. This should be mother. I could have used all this here. It's just, I want it to be clear to the reader that when I'm talking about this, to just always bring in mind the fact that we're talking about the mother here. So for a classic example would be mother.ethnicity. That should be, so when someone reads this, I want them to bear in mind that what's being done here is we're adding to the population a baby, a new person, whose initial age is 0, whose ethnicity is the same as the mother's ethnicity. And so I just want it to be very clear. So instead of this dot ethnicity, where someone reading this would have to like, oh, I guess this is the mother. I just want it to be like blatantly obvious.
So you can just use either this or mother.
I could use either one. They're both references to the same object, so either one would be fine. It would just be clearer if it's like, I think this is vastly clearer than if I had this dot ethnicity. I think that's just asking for confusion. Mother dot ethnicity. It's like, okay, it's the same as the mother. Does that make sense?
Especially because you're introducing a new person right now.
That's right.
That's where I find that confusing. If you're talking about
Exactly.
when introducing a familiar, you're doing this something.
That's right. So I just want it to be clean, so I have offspring and mother. Does that make sense? Now, an important principle here is, so in software engineering, you have to realize not all computer scientists are software engineers. There's lots of computer scientists who are not software engineers. And the code that they'll put out sometimes is just not up to snuff in software engineering. Software engineers are designed to, they're taught to be very, very careful about how they do things in code because they know the risks, they know the need to be very, very careful and to be, to strive for code that's transparent and easily modified, etc. And so you'll find code in any logic example models, which is, it works fine, it probably is pretty good performance-wise, etc. But it's not clean. It's not really hygienic. It's not done in an elegant way, and it's risky. It's risky for changes. Here, what we've done is we have this code. Now, for large number of computer scientists, they would just, instead of having a call to a method here, they would just put it here. Just put all of it. But as I say, a lot of the goal here in software engineering is to minimize the worries on the part of the reader for understanding what's going on. So you have this established offspring connection based on mother's connection. And Carmel is able to understand from just reading the name what that probably does. And the point is exactly that. You shouldn't have to go see this complexity unless you want to. Same thing with that whole thing when the statistics, instead of putting in item.state chart.is state active, it's much cleaner if you just say, item dot, is child, or item dot, is previously infected. And that is something where, it's cleaner, you can understand what it means. If you want to, you can always go look what that method does, but it's cleaner and safer, okay? So here, this establish offspring connections based on mother's connections. Let's go take a look at it, okay? Like what's being done there? We want to know what it does, but if we want to know how it does it, we can go look, okay? So this establish offspring's connections based on mother's connections. What does it do? It takes two arguments. Remember that? It takes an argument to the offspring and mother. In other words, it takes we call it formal parameter to the mother. So it takes a reference to the offspring, takes a reference to the mother, and then it does its job. Its type also is void. What does that mean? That its type is void? Not returning it, it's doing something. And that's also communicated by the name. It establishes the connection. It's changing something. It's not saying compute connections, which might imply that it returns them. It's saying establish them. Perform them. You'll see these sort of action verbs used for naming things. And you could see this a bit of code. Not terribly complex. Software engineers will commonly try for 10 lines or less of real code to sort of make it easily understandable. Anything more than that, they try to carve out sub-pieces and call off to them with nice names. Okay, so what does this code do? Now establish links between the baby and all the mother's connections. Okay, someone here, maybe you can help me interpret this code. What's going on here? First of all, is the flow obvious? Okay. So what does this first bit of code do?
Make sure that you look around.
Okay.
Trying to do something that's impossible.
And
So if the mother has no connections, then it just says return null. Otherwise, it would be freaked out. You'd be trying to get connections when none exist.
yeah, exactly. So the mom might have no other connections, no connections here. It might be that that the mom doesn't have other people to whom she's connected. If we try to go through each of the mom's connections, that will cause problems because we'll say go through each of this and it will freak out. So if you tried to do this without checking if it's not null, what will happen is it will blow up here. Because if this is null, if there's no connection, I don't know what to do, and it'll blow up. And I can almost assure you that's what happened. I got to the point and boom, oh, there's one with no connections. Okay, fine. Let me go put in something to guard against that. If the mom has no connections, that's fine. I don't have any connections to add to the baby. That's fine, not a big deal. Okay, so if the mom does have connections, then what happens?
So for that first agent, you get the connections of the mother. That returns the mother's connections.
This will return the mother's connection.
And then you give those to the offspring in a second.
Okay, that's at a level of abstraction that is what's going on, giving the mother's connections to the offspring. But what's actually happening here is you're determining the mother's connections, and for each of them in turn, each successively, we're going to call A. And for the very first one, we're going to call it A, and we're going to execute this code. For the very second one, we're going to call it A and execute this code. For the third one, we're going to call it A and execute this code. For the fourth one, we're going to call it A and execute this code. So for each successive one of the mother's connections, we're going to perform this code that's in this sort of inside the for loop, okay? And what is this code doing? This is going to look a little bit confusion. What is this first one doing? Okay?
which is, I don't know what that means.
It just means it's treating A as a person. It's just saying, imagine, treat A as a person, and let me give me, by convenience, a name P for it, just so I can refer to it as a person. And then what am I doing with P? How am I using P? The offspring is connected. So for each of the mother's connections, I do this little ritual where I say, okay, I want to name this actually as a person, okay? And then I'm connecting that offspring to the person. I'm going to connect to the person. Does that make sense? So I'm just making it clear, okay, for each of the agent, I'm connecting the offspring up to that person. I actually don't know if, like this offspring.connect to, I don't even think it needs to be connected. Yeah, it just needs to be connected to an agent.
It doesn't have to be a person first.
Doesn't even have to be a person. So like mother.get connections, it actually returns an agent continuous 2D, which we'll get to. So I could actually do this continuous 2D, and then I could actually do connect to A, and this would actually clean it up quite a bit. So it was kind of nice for me to say that they're a person and make it clear they're a person, but really that's not necessary. So by the way, I'm building this just to be sure that oh, look at that. Something's causing trouble. Perform birth. It's having trouble there. Probability of vertical transmission. It doesn't know what it is. Okay, come on. Probability of vertical transmission. What's going on here? Vertical transmission cannot be resolved. Oh, you know what? I used it. I named it here. I said for this case, and I needed to use that. That's all. Sorry. I wanted to make it very clear. Probably like for this particular case. Okay, now it's a happy camper. It actually was fine now. Okay. So this is the code for that first part.
Why did we change this agent continuous 2D?
Oh, because this returns an agent continuous 2D, and that's in fact what this requires. So if you look at what this requires, it requires an agent continuous 2D. So I just thought, since this thing returns it returns the list of agent continuous 2D, and we're doing connect to, so it should, we'll just call it agent continuous 2D, and that will allow us to just clean that loop off.
Previously we thought mother and offspring somewhere else.
Okay, mother and offspring, where do those come from? That's a great question. Where does that come from? That comes from there. These are given to it to do its job. We give it an offspring, we give it a mother to do its job.
Do you have to put them in there, or did you put them directly to the code?
Well, if this requires you to, so what we have is sort of a contract of sorts. This method says, if you give me offspring, reference to an offspring and reference to a mother, I'll establish the connections to the offspring to be sort of mirror those of the mother, okay? To be reflective of those of the mother. That's its job, so you have to give it these things. Now, if we just use these things here, if we didn't have someone give them to it, we wouldn't know who to connect up, because sometimes this method is used with one pair of people, sometimes with another pair, sometimes with another. We wouldn't know who in the population to pair up. So for this to do its job, you have to tell it, okay, connect these two people. This is the mom, this is the baby. Fix the baby up so they have all the connections to the mom.
But we still have to define mother and offspring. Because you have to know that the mother is connected to the offspring that they're together, right?
Right, so here, for this function to do its job, it's going to assume, okay, you have one reference to people, it's going to take for granted that you're giving a legitimate mother, another you're giving a legitimate offspring, and it's gonna treat it, it's gonna hitch the offspring up with all the connections of the mother, including, by the way, we didn't really finish the code, but including a connection to the mother. We're establishing a connection from baby to mother. So that's the job of this method. Now, where is this method being called from? In other words, where is it being used? Is it being used with a legitimate baby and mother? Yeah, it is. It's being used in this place, perform birth, to do that job. So if we go back to perform birth, where is this method in fact being used? It's being used here. Establish offspring's connection based on mother's connection. So this is the baby that was just born to the mother, and so we're calling it off with a legitimate offspring and mother.
So there you're kind of defining what you want.
That's right. And so, and the job of this function it's calling is, assuming they're legitimately a mom and baby, which is kind of guaranteed from this context, now hitch them up to make the baby's connections reflective of the mom's. Does that make sense? And that includes all the mom's connections get offered to the baby, built up to the baby, number one. And number two, the baby gets connected to the mom. So it does all that work. Now I could have put all that code right here. It's just that it's easier to read this code clearly without having to worry about all those details, but just having a call to a method. And if I want to look at it, I could do so. I could go open up that function. So here's establish offspring location based on mother's location. What do you think that does? Yeah, it spatially puts them. So let's go look at that, right? What is that? What are information we're giving that? The offspring and the mother at issue. So we're asking it, hey, for this particular offspring and this particular mother, take for granted that they're an offspring and mother. Now go off and could you do this service for me? Okay, so here's establish offspring location based on mother's connection. And this is the code for this, okay? So here we have the code for this thing. So what are we doing here? This is a little bit complex, but the idea is we're gonna put the baby at some distance from the mother, some fixed distance as specified by parameter in main, and then we're going to draw the angle the baby's at from a distribution, and then we're going to set the offspring's x and y location to be the same as the mother's, but some distance from it. And so here we have some angle. We have some, this is maybe where the mother is at this origin point, and the baby is some distance from the mother, so it's on some circle here. And we determine the angle within that circle from this between 0 and 2 pi, and then we say, okay, there's a sine and cosine here, and so the x location is the mother's x location plus the cosine of this angle. It's called theta, and so this is the x and this is the y, and so we put that on. So we sort of put the baby at some random sort of it's a fixed distance from the mother, but in a random angle. So that's how we set the baby's location. Again, I could have put this code into that perform birth, but it would have been messier. It would have been messier if we had just gone and pasted it in here directly, and perform birth directly. So here we're dealing with situations where there's as much aesthetics involved as anything else. Sure. Sure.
Would you go back to the
I don't know why.
established connections one?
Sure. So just a second here. I think it's really making my computer go slow, and I'm not sure what it is right now. But, so just a second. So establish offspring's connections based on mother's connections. Yeah, okay.
So in there.
Yeah.
Where you just said to,
Ah.
continue to be.
Yeah,
Is acceptable. If you had two types of people agents
yeah,
in there, you would have to move the other one that you had originally, right? So you should those only as, person agents and not dog agents, for instance?
Yeah.
Not dog agents anymore?
yeah, right.
Is that correct? I'm gonna be doing stuff like that, so.
Yeah, you'd want to check, is this indeed a person agent or is it a dog agent? And if it's a person agent, maybe you want to connect the baby to it, but you don't want to connect the dogs to it.
Exactly.
Yeah, yeah, you can do that right there. Yeah. Okay.
Found that little chunk of code, you know, before really into it.
Yeah, okay.